Hello everybody, welcome back to Human Resource Machine. Before getting on to the next level, I wanted to check something about string storage floor. So the thing I was curious about is, you know how they always randomize the inputs so that you can't just hard code all the specific outputs for that one specific input and then cheese the game like that? Well, the output for this level is a specific message, and I don't know if they can spell a different message with these letters. So I'm wondering how that actually works. Can I just hard code the output message in my solution and have it work that way? Or is there actually a different message that it can spell? And that would be a pretty cool Easter egg if they did have that, because most people wouldn't actually see that other message. So let's try that. We know it starts with like the target, so I'm gonna take the first one from the inbox but completely ignore it and just make my own message. So T H E. Oh yeah, here we need to get another input. And then the next input corresponds to T A R. And then one more input, that would be G E T. Yeah, I think I got the number of inputs correct. Let's try that. Oh, I see. Yeah. Okay. So I see how that works. As a bonus, we did improve our number of steps a lot. But yeah, okay. The core message, the target is awake, take this, doesn't change, but what changes is the number of X's that they insert in the middle of the message. That's why we had a bunch of random X's showing up in the middle of the message. So the thing that you need to get right is the number of X's, and that depends on the input. Got it. That's something I was curious about. Let's continue. Level 34 is Vowel Incinerator. Okay. What's the meaning of the management is attempting to reduce bandwidth by removing all vowels from every word. Gluck. Send everything from the inbox to outbox except for vowels. Okay. This should be easy. We take inbox. I guess copy it to a slot because we need to compare against all the vowels. Let's have another. Okay, this slot is our letter. Next slot is going to be our index. So initially, I want to copy from 0 and put that into our index because that's where we compare. Copy to letter, and then now we're going to start subtracting. So we have the letters, subtract the letter at address index, and then if it's 0, that means it is a vowel, so we skip everything. In fact, we just get from the next inbox. If it is not 0, that means it did not match the current vowel, so we need to bump up the index and copy to letters. Okay, so we need to get our letter again, jump back here so we compare against the next one. Now here's a little problem. which is if we get to the end, we bumped our index by, actually, before we do that, we need to reset the index back to 0. Okay. Yeah. Here we bump the index, and we have to check if the value addressed by our index is 0. So if that is 0, then we're done comparing against all the vowels, and none of them matched because none of them caused us to jump back to the beginning. So this is where we still need to copy from letter before we do that. Output the letter, and finally jump back to the beginning and proceed with the next letter. Let's try this. Okay, not bad. We are almost there to the challenges. Yeah, so I immediately am thinking about the same pattern that we had in the other problem where we were counting how many matches we had on the floor, where we had pretty much the same loop over here, and we can apply the same kind of optimizations there. So the first thing we did was copy from letter, got moved to the top. And then, because we're just comparing the letter with the index here, it doesn't matter which one we subtract. So I'm gonna get the index here and the letter on this one. And now we have copy from index, copy from index. Now that's 2 copies of the same thing, so we don't need both. And jump if 0 needs to go up here. That should save some instructions. Alright, we did it. Number 35 is duplicate removal. You're fired. Just kidding. But I do have a note here from your other supervisor. She's out sick today, but she says, it's time to eliminate inefficiencies. That's what we do every day. And that's it. Send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. Okay, so with these inputs, every time we see a new one, we're going to have to write it on the floor. And then when we get an input, for each input, we're going to have to compare it against everything that we've seen so far. Make sure it doesn't match any of those. And if it is new unique value, then we have to put that one on the floor, but also send it to the output. So that's the basic idea of how we're going to do this. So let's get the value, and then we're going to need to compare it against everything we have so far. So let's copy it to a slot. So this is going to be our letter. And then the 0 here, I'm going to make this the number of unique things that we've seen so far. So it starts at 0 because we don't have any unique values on the floor yet. And then to iterate through them, let's say we already have like 2 of them, we will want to copy from this to another cell. I'm going to call this the index. And initially I want to bump the index down because indices start at 0. So if this was like 2, for example, then only cells 0 and 1 would be populated. So index starts at 2, you want to bump this down to get to the actual second value, because there's not going to be anything in cell 2 when index is equal to 2. Okay, bump this down. We get our letter back. Yeah, actually, can we do this in a different order? Let's set up our index first, so that when we do this, we don't need to copy from letter again. We already have the letter in our hands. Let's compare that against the value at address index. If it is 0, that means it matches, which means we want to completely ignore this and go back to the beginning where yes, we do need to, because we're going to be modifying index along the way. Otherwise, if it does not match, then we bump down the index, and then we'll have to check if index has become negative. If index has become negative, it means we have finished checking all the values and we didn't find any match. So in this case, we'll want to get our letter and send that to the outbox. This is the successful path. Jump back to the beginning. Oh wait, something else. Copy from letter, and then we'll have to write that out to the floor. So that's going to be the address of num unique. We're going to have to bump up the number of unique items as well. So this is if we find a new unique thing, it didn't match anything above. We take the letter, copy it to a new slot, also send it to the output and increment this value so that we know we have a new unique value. Alright, let's try this part. If it is not negative, it means we did not finish iterating through all the values that we've seen before, which means we want to continue on to the next value. The next value is somewhere around here. Something like that. Okay, let me check again. I set up the index. Starts from num unique. This is good. We get our letter. Oh no. Copy to letter, but then we need to copy from letter again. So inbox, we save the letter. On each iteration of the loop, we get the letter, subtract the value that we're checking right now. If it matches, go back to the beginning, because we're just throwing away, that's a duplicate value. So we throw it away, go back to the beginning and redo everything with a new input. If it does not match, then you bump down the index, go to the next one, and assuming index is still valid, then you come back and do this again. Okay. I think that is okay. Let's try it. Tiles with address -1 does not exist. Yeah. Okay, so why am I still doing that? Okay, yes, I just need to, okay, so it can be negative right here. So let's do jump if negative, but we need the value of index here. So let's copy from letter. Okay, let's just put another bump minus index. Oh wait, okay. Initially, index is going to be -1. This is correct. Inbox, we still... Actually, if we don't have anything to compare with yet, then we can skip this whole thing. So jump if negative. Ooh. Okay, jump if negative, skip the inbox stuff. But we do need to... We still need to copy it to the unique and send it to the outbox and stuff. So inbox goes here, but on the other branch, we'll need to copy from letter and then send that to the output. The rest, once we get over here, we know index is not negative, and so we can continue doing our normal loop. Let's try that. Yeah, I was pretty sure it was not super efficient. Let's improve it. The first thing we can optimize is this jump if negative, where you have two places where you get stuff from the inbox and you have an extra jump over here. This looks really messy and really complicated. So I think we can actually move these up here. Originally I had these down here because I wanted to use the value of letter immediately to compare against sub. But since we're doing this in a loop anyway and we're saving the value of letter, then we don't need to worry about destroying the value. So let's do the inbox stuff first, then set up our index, and then here we'd have the value of index in our hands, so jump if negative, and we can just remove this, have this jump come over here so that we read the letter back from memory instead of getting it from inbox. And then now we don't need this jump anymore. So both of these branches, whether we have nothing to compare it against in the first place, or we've finished comparing everything and didn't find any matches, both of these branches will use the same code to output. That saves a few instructions and should get us the program size challenge. Yep. Now we just need to optimize speed a little bit. And we can do even better. So first of all, there's no reason to compare index for this jump. We can just jump directly from here. If the number of unique is 0, then we know we are in the first iteration where we haven't found anything yet. We can just jump directly to 0 and not worry about any index at all. The second thing is I see bump minus index and bump minus index. This is a duplicated instruction. So if we make this jump include one more instruction, then we don't need this one anymore. But we also need to move the jump if negative up here so that it comes right after we bump the index, so we can test the index properly. That reduces by one more instruction. Okay, so our size decreased by 1, but the speed got even worse for some reason. So we're going to have to work on the speed. Sorry, just one more thing. Now that since we have bump minus index before any of our looping happens, and we're already testing if index might be negative, there's actually no point testing if our initial number unique is 0. Because once we get down to the index here, we are going to test if it's negative up front. And so we can remove that jump altogether. That's going to save one more instruction. Now it is going to make the program even slower because we need to execute more instructions before we get out. But it saves an instruction. Yeah, see, now we're 2 instructions down from the size challenge, and our okay, somehow we became faster than last time. That's weird. I don't know how that happened, but okay. So I don't see any obvious ways to make this program any faster. It's because this loop is where the program takes the majority of its time, and this is where we take each one of our inputs and for each one, compare it against every one of the letters we've seen so far. And the loop is already pretty much as tight as it can be. I don't see any ways to make it more efficient. So if we want to increase the speed, we're going to have to try a different approach. So let's do that. The approach I want to take here is, I'm noticing that the inputs are kind of limited, right? So here we only get the letters A, B, C, and D. And that's it. We don't need to make a long list of anything. And knowing that the inputs can only be A, B, C, D, we can do something like reserve these slots 0, 1, 2, 3 to indicate A, B, C, and D. And the idea is, if we have not seen the letter previously, then we have a 0 in here. But if we have seen the letter previously, then we have a 1 in here. That way, down the road, let's say we're checking the letter B. We want to see if we have seen the letter B before. In that case, all we need to do is check this one slot and see if it's a 1 or not. We don't need to do any comparisons. We don't need to iterate over a list of letters. So that'll make things a lot more efficient. So what I'm going to do is initially set up these slots. So I'm going to copy from 0. I'm going to copy it to each of these slots. Okay, I'm going to take the first letter, that's going to be the A. I am going to put that here. So this is going to be our first letter. And the first letter is going to occupy slot 0. So to mark the fact that we've seen first letter, I'm going to bump up slot 0. And then I will send the letter to the outbox. And we are done with the first letter. Now we're going to get our next letter. The next letter, we are going to subtract that against our first. That'll give us the index of which slot it's going to be. So A minus A is going to be 0, so that's still going to go into slot 0. C minus A is going to be 2, and that's going to redirect to slot number 2, which is reserved for C. So we're going to copy that to an index slot, and that's only because this is required to reference the cell indirectly. We're going to get the value at address index. This will be one of these cells, and it'll be either 0 or 1 depending on whether we've seen the letter before or not. If it is 0, that means we have not seen the letter before, and we are going to bump up the value at address index to mark the fact that we have seen it. We're going to inbox. Okay, maybe we need to save that. So this is our current letter, or let's call it current letter. Okay, and now we're going to copy from our current letter, send that to outbox, and now we can get back to the next input. That is if it is 0. If it is not 0, that means we have seen the letter before, and so we don't need to output any of this stuff. We can just go back to the inbox. Let's see if that works. Aha! Your solution works with these inputs but fails on other possible inputs. So let's see what it gives me, because I knew there was going to be problems. Okay, so two differences. Number one, it has the letter E. Number two, it starts with B this time instead of A. And so if B occupies this slot, then A would theoretically occupy slot number -1, which doesn't exist. And so part of this doesn't quite work. But don't fear, I have a solution for that. Instead of using 0, 1, 2, 3, let me actually start with a slot. Let's do 5. So I'm gonna do this. In fact, I'm afraid I'm gonna have to do quite a few. So 1, 2, 3, 4, 5, 6. I know this looks really stupid, I will explain it. 8, 9. Okay, we got everything populated with zeros. So when we do this, you can see all of these are going to be populated with zeros. So why am I doing that? It's because the first letter can be anywhere between A, B, C, D, E, and the rest of the letters can also be anywhere between A, B, C, D, E. So in the best case scenario, our first letter is an A. My plan is to use number 5 as the slot for our first letter. So let's say our first letter is A, then we need enough space to do A, B, C, D, E. That's why we need it up to slot 9. But if our first letter happens to be E, then we need space for E, D, C, B, A, going backwards. That's why we need it to start from 1. That's why we need all these slots to be occupied. Now, we also want to increment this number to a 5 to indicate that the first letter is going to occupy slot 5 and give us a way to calculate that. So I am going to bump up slot 14 5 times. Okay, now slot 14 is going to contain 5. Now, inbox copy 2, this is copy 2 first, correct? And then bump up number 5, because this is where we store our first letter. And then everything else, the current subtract the first will give us the index, but remember our index starts at 5. So we also need to add 5. And now we copy this to the index. This will be our index of the letter. We're going to do everything else the same way. And this way it'll take care of letters A, B, C, D, E, and no matter what the first letter is. Oh yeah. Yep. Exploiting structure of inputs gets us very good results. And notice this only works under the assumption that inputs can only be A, B, C, D, E, right? If it gives us more possible letters, then this method would not work. But hey, cheesing games is more fun than not cheesing games, so. Alright, so I'm going to stop here for today. I know we didn't do very many levels, but they are starting to get more challenging and they are taking a longer time to solve. So next time we come back, we will pick up with level 36 Alphabetizer. That's it for today. Thanks for watching. See you next time.